By now, you all know that I love to use Microsoft Excel. In this class, I'm going to show you another very useful tip that you can use Microsoft Excel to greatly simplify your life. Specifically, I'm talking about integrating the heat capacity in order to find what the change in specific enthalpy is. So in class a couple times ago, I said that the formula that you use to figure out what the change in specific enthalpy when you have a change in temperature is the integral of Cp dt. And the Cp you have to look up from table B2, and that can oftentimes be a 4-term polynomial. And integrating that is easy enough, but it's rather tedious. And so therefore, I want to show you how you can use Microsoft Excel once again to program yourself a calculator that you can do these calculations very easily. So again, part of the beauty of Microsoft Excel is that you can do something one time, and then you can simply use that same array of cells in order to do calculations in the future. So I'm going to show you what my Excel calculator looks like. And the other beauty of Excel is that you can change it to look however you'd like. So if you try to look up on the internet, for example, a CP calculator, I don't think that one exists, kind of like the interpolation calculator. But if you save this spreadsheet, you can use this in order to perform these integral of Cp dt calculations. So in my examples, I've just got acetone vapor and acetone liquid, and I'll show you 2 different ways. And then the beauty of it, once again, is that you can just copy this as many times as you want, and you can calculate what the delta H is. So I'll take you through each cell that I have. The first 2 cells are my T1 and T2 cells, and I've highlighted these light yellow, and that signifies to me that I need to input a value for these. So depending on what temperature I'm changing my acetone vapor to, that is going to affect what my T1 and T2 is. Let's just say, for sake of argument, I'm going to start at, I don't know, let's just pick a temperature 80 degrees Celsius, and I'm going to heat it until 105 degrees Celsius. Now you notice when I put in those temperatures, my delta H changes. I'll show you how that happens in a moment. In these cells, I have values for the constants A, B, C, and D. And here is where I am inputting stuff directly from table B2. So I might shade this in a different color to signify that this is input that I must put in. So I'll do the same thing for the liquid. So these are the entries from the actual table. And remember, there's that weirdness in table B2 where you have to multiply it by a power of 10. That's what I've done in this cell. So this cell is going to convert it to the actual value of A from the table entry. So while the table entry for acetone vapor is 71.96 for vapor acetone, remember that the value of A must be multiplied by 10 to the minus 3 in order to get the true value of A. Same thing for B, where I've taken this cell and multiplied it by times 10 to the minus 5. This cell is times 10 to the minus 8. And finally, D is multiplied by 10 to the minus 12. So once again, the first part of this calculator is just very easily converting the value from the table to the actual value. And once again, if that changes, or if I want to do a different chemical, I can just click a different number in here. So let's say 84, for example, it'll automatically convert it for me. Right, so I'm just importing directly from the table what those values are. Now the last cell that I have is going to be the formula for delta H hat, and this is the integral of Cp dt. So just to help you out in reading this formula, if my Cp value is this 3rd order polynomial, then I can integrate that just term by term and obtain the following expression. Now when I plug in T2 and T1, those are going to be obviously plugged in for T. So I'll just leave this formula up for a moment. I don't want to go through and read it to you because I definitely think I would mess it up. But just notice how this formula can be a little bit tricky to put in the first time in Excel. You got to make sure that your order of operations is correct. You're using your parentheses correctly. But once you've done this again, my point is that once you put this formula in, that's all you have to do. And now if you want to use this calculator again, so once again, make sure that this is right, because if you keep copying and pasting it, you want to make sure that it's going to give you the same thing. It will just spit out what the value in kilojoules per mole is. So once again, I'm just going to go back to this. Pause the video here if you want to go back and look at this formula in more detail, or maybe even make your own calculator. So this is what I was talking about. So say I want to do a different chemical. I'm going to copy this, and I can go to a different part of my spreadsheet and I can paste it. I don't want to paste the values. If you just paste the values, then the value in this cell is a number. It's not a formula. You definitely want to make sure that you're pasting the formulas. So let me undo this. And when I go back into paste, I want to paste the formulas, f of x. And you should always be able to go back in and double click, or just click the formula bar, and it'll highlight the cells that it's referencing. So I want to make sure that I'm highlighting these cells. And it didn't take my formatting either, which is kind of sad, but that's okay. So say I wanted a different chemical now, I could just put in benzene. I would then remove all these, this stuff, and then I would just put in the values from the table once again, and it would automatically calculate everything for me. So I hope this video was very short, sweet, but very useful. I definitely recommend that you make your own calculator like this in Excel, and also look for ways that you can make your own calculator for other types of tedious calculations for which you maybe don't want to plug it into your TI-83 every time. I definitely don't blame you for not wanting to plug in all those zeros to your TI-83. It's definitely easy to make a mistake. Oh, notice, by the way, that when I'm referencing these A, B, C, and D constants, I'm referencing the actual value, not the value from the table. That was all from this video. Once again, I'll just leave this up in case you wanted to pause the video now and see what my cell references are.